Okay. Question 7. A uniform wooden stick of mass 1.16 kg of length L rests in an inclined manner on a smooth vertical wall of height h less than L such that a small portion of the stick extends beyond the wall. The reaction force of the wall on the stick is perpendicular to the stick. The stick makes an angle of 30 degrees with the wall and the bottom of the stick is on a rough floor. The reaction of the wall on the stick is equal in magnitude to the reaction of the floor on the stick. Okay. The ratio H upon L and the frictional force F at the bottom of the stick are, take G as 10, root 3 by 16, 16 root 3 by 3, 3 by 16, 16 root 3 by 3, 3 root 3 by 16, 8 root 3 by 3, 3 root 3 by 16 and 16 root 3 by 3. Okay, let's read the problem again. There is a ladder or a stick that rests in an inclined manner on a smooth vertical wall, height h less than L. Small portion of the stick extends beyond the wall. Okay, so suppose this is the floor and this is the wall. Okay, there is this ladder the pole that rests on it, and some of its portion slightly extrudes the thing. Okay, so let me show the ladder in red. Keep on saying ladder. Stick. Let's keep the stick like this. Okay, fine. The reaction force of the wall on the stick is perpendicular to the stick. Let me show the reaction in blue color. It is perpendicular to the stick, so it will be like this. Let's call it R. Okay, let us call it R. The stick makes an angle of 30 degrees with the wall. Stick makes an angle of 30 degrees with the wall. And the bottom of the stick is on a rough floor. So rough means it will have both friction and normal reaction. The reaction of the wall on the stick is equal in magnitude to the reaction of the floor on the stick. Okay? Wall on the stick equal in magnitude to reaction of the floor on the stick. So this should also be R. Normally we would define R1 and R2, but now no need. R1 equal to R. Okay. Now tell me, in which direction is the stick may travel? To the right or to the left? The bottom end. To the left, of course. Right? Unless somebody pushes it, it's unlikely that the stick is going to get pushed to the right. Okay? Or closer to the wall. So, okay, its impending motion will be in this direction. Correct? Impending motion will be in that direction. So the frictional force will be in the opposite direction. Okay, and they have given a letter for the frictional force, that is F, so I am going to use it. Is that clear? Any other force that remains to be shown? Weight needs to be shown. Mass 1.6, G 10, so weight will be 16. Let me show it at the midway. Okay, so there are 4 forces acting on the ladder, and under these 4 forces we have to assume that it is in the impending motion state. Okay, fine. Let's now apply the equations of equilibrium. Summation Fy equal to 0. Okay, summation Fy equal to 0. R minus 16. R means the bottom R, and nice. Okay, so this will be 60. Right, this will be 60. So the vertical component of this reaction at the wall will be R by 2, R cos 60 or R by 2, and that is equal to 0. Is that clear? Capital R minus 16 plus R cos 60 or R by 2 equal to 0. Understood? So can I say that R is 32 by 3? Because see, R plus R by 2 will be 3R by 2, 16 send it to other side, then 3R by 2 is 16, so R will be 2 into 16 by 3, so 32 by 3 meters. Clear? Okay, summation fx equal to 0. F, okay, f minus r sine 60 or root 3 by 2 this time. And why negative? Negative because that horizontal component will be to the left. Okay, negative to the left. So f is obtained now, f is ready. It is root 3 by 2 into r, but r is 32 by 3. So it is 16 root 3 by 3 or 16 by root 3 newtons. 16 root 3 by 3. So C is not there. So A, B or D. Okay, so we have to now find the ratio of H and L. Okay. Now this is actually a problem of 2D equilibrium. Okay, so which equation remains to be taken into consideration? Moment equation. Agreed? We need to take into consideration the moment equation. Okay, the convenient point to take the see, you can take moment about any point. Okay, let's take about this. Okay, I'm going to call it C. So if we take moment about point C, okay, if we take moment of all the forces about point C and equate it to 0, what are we going to get? Let me do one thing. Let me paste this figure below so that I'm not required to scroll it and even you people can focus more on it. Okay. Now please pay attention. Moment is force into perpendicular distance in two-dimensional version. Correct? So R into what? First of all, look, if only R were acting, the wall reaction, it would have produced anti-clockwise moment. Agreed? So take it positive. Take it positive. Now see, do not take length of the ladder because they have deliberately mentioned there that a small portion of the stick extends beyond the wall. Okay. So now we have to bring in the height of the wall in play. Okay. What is height of the wall? Height of the wall is h. Okay. Height of the wall is h. Okay. So the moment arm for the reaction will be what? Pay attention. Consider that right triangle. Let me call it RCB. Okay, RCB. Okay, cos 30 will be h upon the length that you want. Okay, right? H upon the length that you want, that will be cos 30. Do you agree? This 30. Adjacent upon hypotenuse is cos. So the length that you want will be h sec 30. Clear or not clear? Clear. Now, the other thing that is going to contribute to the moment is the weight of the stick, and it is clockwise. So, we need to consider negative because we are considering anti-clockwise positive. 16 into what? 16 into this distance, perpendicular distance, okay? Now, this time bring in length of the ladder into play and use the word uniform. Uniform means weight is distributed equally everywhere. Okay, so it will be L by 2, but not just L by 2. Okay, L by 2's projection on BC. Now this angle will be 60. Right, it goes without saying that this angle will also be 60. Right. So it will be cos 60. So L by 2 into 1 by 2 equal to 0. Right, now what do we want? Do we know R? So R is 32 by 3. So 32 by 3 into 2h by root 3 equal to, send this to other side, 4l. They ask us to determine h upon L. Right, h upon L. So that will be 4 into 3 root 3. Okay. 4 into 3 root 3 upon 64 or 3 root 3 upon 60. 3 root 3 upon 16. Okay. Okay, option D is right. H upon L is 3 root 3 by 16, and F we had already found it out. 16 root 3 upon 3.